Okay, today I'm going to talk about section 10.2. So here, so section the 10.2, so calculus with parametric curves. The first, I just review some of the last lecture very quickly. So we have two parametric equations. The x equals the f of t, the y equals g of t. We have this one. So we can draw graph of this one. The graph is like this, like this one. So this is like a direction. This is parametric curve. I can choose one point here. You can draw tangent line. You can draw tangent line here, so like this. This is a tangent line. So what's like a slope tangent line? So we know the slope of the tangent line is ty over dx, because this is x-axis, this is y-axis. So what's that? I want to use parametric equation. So exactly same to dy over dt over dx over dt. The same to g prime of t over f prime of t. So this is slope of the tangent line. So one more. How can you find the second derivative? The second derivative, d square of y over dx square. What's that? The derivative of the first derivative, dy over dx with respect to t over dx over dt. So I want to use regular prime notation. So we have a first derivative g prime of t over f prime of t. This is a whole prime over f prime of t. So this is exactly the second derivative. So one more. How can you find equation of this tangent line? So we have here, we think about the equation of a tangent line. The equation of the tangent line is like equation of tangent line here. At this point, so in this case, t equals like given number a. So first, you can find x component of this point. You plug a into here, f of t. So f of a is x component. You can plug a into g of t. So y component is the g of a. So what's like equation of tangent line? I want to use point slope form. What's like a point slope form? Point slope form is like this. So we have y minus y component g of a equals the other slope? Slope is here. dy over dx. dy over dx. dy over dx. at t equals a times x minus x component f of a. This is equation of the tangent line. So one more. So we can choose this point. We can draw tangent line. Tangent line is horizontal. So we have the horizontal tangent line. The horizontal tangent line here. So we can say, we can write this is t equals like a. So what's that? We have the horizontal tangent line. Horizontal tangent line at a. So what's that? The slope of tangent line equal to 0. So we have ty over tx equal to 0 at a. Is right at a. So this is equivalent to this one. dy over dx equal to 0, exactly this one equal to 0. So exactly this one equal to 0. So which one equal to 0? Top one equal to 0, but bottom one is non-zero. The top one is ty over dt equal to 0, but dx over dt is not equal to 0 at a. So we have horizontal tangent line. So one more. So we have vertical tangent line here. At this point, so we have the like vertical tangent line. We have vertical tangent line. Vertical tangent line. So we have the vertical tangent line. Vertical tangent line at A. What's like definition? So what's like a slope vertical line? The slope vertical line is undefined. So ty over dx is undefined. So we have ty over dx is undefined. So we have two cases of undefined things. So here we have first case. What's the first case? Here. Bottom one equal to 0, but top one is non-zero. So we have first case, dx of dt equal to 0, but top one, dy over dt. dy over dt. Top one is non-zero. This is one possibility. The second possibility is this one. dx dy over dt, the top one equal to 0, and bottom one equal to 0. We have two cases, top one 0, bottom 0. So one more. In this case, take limit. T value approaches A, the absolute value of dy over dx. What happens to slope? So I can show it to you. So here, the t value, this is choose t value approaches here, t equals a. The t value approaches a from here to here. What happens? You can choose t here. This is tangent line. You can choose this one. This is tangent line. So what happens? T value approaches a. The slope of tangent line is increasing, going to positive infinity. So opposite way, you can tease here. This is like a slope tangent line. This point, this is a slope tangent line. The slope tangent line is decreasing, like going to negative infinity. Take absolute value, this is going to positive infinity. We have two possible cases for finding vertical tangent line. So we have this kind of things. So another one. So another one is here. So what is this one? Second derivative, the square of y over dx squared is positive. So what does it mean? The graph is concave up. The d square of y over dx squared is less than 0, concave down. Concave down. We have the two cases. This is exactly section the 10.2. You need to know these kind of things. Next, I want to give the one example by using these concepts. So here we can erase everything. It's clear. I want to give the one example here. Would you like example? This is like example. So we have parametric equation x equals cosine of t, y equals sine of t. The t is between 0 and 2 pi. 2 pi, so like this. So we just only think about like this. Just wait. The first problem A. Find an equation of the tangent to the curve C at t equals pi over 6. This is the first problem. Second problem, find the point. Find the point on C, where a tangent is horizontal or vertical. Horizontal or vertical. Second problem. The third problem. Determine where the curve is concave up or down. So like this. So if you want to solve the number A and number B, you need first derivative. So you can calculate the first derivative. So here, what's like dy over dx? So dy over dx is usual definition, formula. dy over dt over dx over dt. You can use a formula. What is dy over dt? dy over dt is y prime. Y equal to sine of t. So we have sine of t prime over dx over dt is x prime, cosine of t prime. This one. The sine of t is cosine of t. Cosine of t prime is negative sine of t. You can find the dy over dx. So next tip, you can solve problem A. So how can you solve? You can use this one. Do you remember? I can remind this one again. So we have curves like this. Here you can draw tangent line. This point is like t equals a. Was like equation of tangent line y minus g of a equals ty over tx at t equals a times x minus x component f of a. Is right? So like this. So in this case, here this point is f of a. So this point is like g of a. Remember this one? The x equals function of t, the y equals g of t. We have this kind of things, but we have it. So first, you can find dy of dx at t equals a. In this case, t is given. The pi of 6 is like a. So you can calculate slope of the tangent line. The slope of tangent line is dy over dx at t equals pi over 6. So you plug pi over 6 into t, cosine of pi over 6 over negative sine of pi over 6. We have cosine pi over 6 over negative sine of pi over 6. Cosine pi over 6 is root 3 over 2. We have root 3 over 2 over. Negative sine pi over 6 is the negative 1 over 2. So root 3 over 2 times the reciprocal of minus 1/2 is negative 2 over 1. The 2 is crossed out. Answer is minus root 3. This is slope. The next you can find the x component f of a. Was it like a function f? Here, this is the first one. X is like f of t, y equals g of t. So you can find f of a. Was it like f of a? F of pi of 6. You plug pi of 6 into x component, cosine pi of 6. Cosine pi of 6 is root 3 over 2. Was it like g of pi of 6? G of pi of 6 is like plug pi of 6 into sine function. Sine of pi of 6. Sine of pi of 6 is 1 over 2. We have these numbers. Was it like equation? Equation of the tangent line is, we can use this formula. Y minus y component. Y minus y component 1 over 2 equals slope is here, negative root 3 times x minus x component root 3 over 2. So simplify. Y minus 1/2 equals, distribute negative root 3 to the x and the minus root 3 over 2. The negative root 3 times x plus 3 over 2. You add 1/2 to the both sides. 3 over 2 plus 1 over 2 is 2. So final answer is y equals minus root 3 x plus 2. We have this one. This is equation of tangent line. So we have it. The second one. How can we solve the second one? The first one, we think about horizontal tangent line. What's it like a horizontal tangent line? Horizontal tangent line. Horizontal tangent line. So what's that? Do you remember? What's the horizontal tangent line? dy of dx equal to 0. So we have the first case, dy over dx equal to 0. dy over dx equal to 0. So exactly this one equal to 0. So which one equal to 0? 탑은 cosine of t equal to 0. Negative sine of t is non-zero. So we have this equation. Cosine of t equal to 0, but negative sine of t is not equal to 0. So how can I solve this problem? So let me see. So I can draw sine and cosine function. This is very helpful. I just only erase here. This one. So was it like cosine and sine function? The cosine function is like this. Cosine function. This is cosine of t. This is pi over 2. This is pi 3 pi over 2. This is 2 pi. This is pi. What's the sine function? Sine function is here. This one. This is sine of t. Pi over 2. Pi 3 pi over 2. And 2 pi. So cosine of t equal to 0, which angle? The pi over 2, 3 pi over 2. So we have this one. The t equals pi over 2 and 3 pi over 2. So we have it. The next thing. This inequality is satisfied or not. You plug pi over 2 into sine function. Negative sine pi over 2 is minus 1. Minus 1 is not equal to 0. It's good. Satisfied. 3 pi over 2 into t. Negative sine 3 pi over 2 is minus 1 times minus 1 is positive 1. The positive 1 is not equal to 0. Yes, we have two t values. What's the like equation? Find the point on the curve C. So you can plug pi over 2 and the 3 pi over 2 into x and y. So first one, the t equals pi over 2. You can plug into x. X is cosine pi over 2. Cosine pi over 2 is 0. You can plug into y. Y equals sine. Sine pi over 2. Sine pi over 2. Sine pi over 2 is 1. The next, t equals 3 pi over 2. Same. Plug into x. X is cosine 3 pi over 2. Cosine 3 pi over 2. Cosine 3 pi over 2 is 0. Y value. Sine 3 pi over 2. Sine 3 pi over 2 is negative, 1, right? Yes, negative 1. So we have the 2 points. From the first case, x component 0, y component 1. It's the second case, x component 0, y component minus 1. We have 2 points. So we have horizontal tangent lines at 2 points, 0, 1, and 0, minus 1. So we have this answer. The next one, vertical tangent line. Here, vertical tangent line. So what's that? We think about case 1. What's it like a case 1? So case 1 of some the vertical tangent line from the previous page. So what does it mean? T, Y, here, page. Ty over dx, Ty over tx is undefined. Undefined. So what's that? This is same to the case 1. So ty over tx over dt. tx over dt. tx over dt is exactly bottom one. Bottom one equal to 0, but top one dy of dt is not equal to 0. So what's that? So we have dx of dt equal to 0. Which one equal to 0? Bottom one. Negative sine of t equal to 0. Negative sine of t equal to 0. But top one. Cosine of t is non-zero. So we have cosine of t is non-zero. So what's it like t values in this case? So sine t equal to 0. We have the sine function here. Angle 0. Angle pi, angle 2 pi. We have t equal to 0 pi 2 pi. So you can define x component, y component. The t equal to 0. What's that? You plug into x. X equals here, cosine. Find cosine of 0. Cosine of 0 is 1. You can find y value. Y equals sine of 0. Sine of 0 is like 0. So we have 1.10. The next one, t equals pi. You plug into x and y again. X equals cosine of pi. Cosine of pi is -1. Y equals sine of pi. Sine of pi is like 0. So we have another point, -1, 0. The t equals 2 pi. You plug into x and y again. X equals cosine of 2 pi. Cosine of 2 pi is 1. The y equals sine of 2 pi. Here, sine of 2 pi. Sine of 2 pi is 0. So we have the 1, 0. So what does it mean? We have 2 points. The 1, 0 and -1, 0 because bottom 1, 0 is exactly same to first 1, 0. So we have 2 points, 1, 0 and -1, 0. So we have vertical tangent line. This is like the answer of B. So next one, you can check concavity. How can some define concavity? So we can use second derivative, the second derivative. How can you find the second derivative? So from here, you can define the second derivative. You can find second derivative. What is like a second derivative? D over dt. What's that? The function is first derivative dy of dx over dx over dt. It's like a definition. So what's the first one? dy of dx is here, negative cosine of t minus sine of t. So what's that? Here. We think about this one. Was it like a cosine of t, sine of t? I can change it. This one to the keep negative. Cosine of t, sine of t is cotangent of t. You can plug cotangent of t into here. So we have the negative cotangent of t prime over dx of dt is here. The dx of dt is same to cosine of prime negative sine of t. And calculate. The cotangent prime is negative cosecant square. The -1 times negative cosecant square is positive cosecant square of t over negative sine of t. And change it. Cosecant is 1 over sine square. Negative sine of t. And simplify 1 over sine square of t times. The reciprocal minus sign is 1 over negative sine of t. What's that? Negative 1 over sine cube. This is exactly second derivative. So next, you're going to see. Was it like a concave up? So graph is concave up. So when do you have a concave up? Only second derivative is greater than 0. So second derivative is negative 1 over sine cube t is greater than 0. So what does it mean? top one is negative, bottom one is also negative, the fraction is positive. So we have bottom one sine cube t is less than 0. The three is like other power, just sine of t is the less than 0. We have concave down. So which t value has negative sine function? We can use graph of sine. T is between pi and 2 pi. So sine t is below t-axis, negative number. So what is like a t value? The t is between pi and 2 pi. This is answer of concave up. So concave down. What's concave down? Opposite. Concave down. The second derivative, the minus 1 over sine cube t. Sine cube t is less than 0. So top one is negative, the bottom is positive, this fraction is negative. So we have bottom one sine the cube t is greater than 0. So what's that? 3 is like the same, odd power, only sine function is positive. Sine of t is greater than 0. So what's that? Here, sine function is this one. The sine graph is above t-axis. This is only positive from 0 to pi. So t value is between 0 and pi. So that's it. This is the whole idea of solving this problem. So one more. I just only identify these answers make sense or not. I can check by using graphic. What's like a graphic? So x equals cosine of t, y equals sine of t. So we have here x equals cosine of t, y equals sine of t. What's that? Scale both sides. Scale both sides. And add these two equations. X squared plus y squared equals cosine squared plus sine squared is 1. So we have unit circle. So graph is like this. We have unit circle. Unit circle. So what's the direction? Direction is the counterclockwise direction. This is like 1 was a t value, t equaled 0 and 2 pi. So from the month, I think some yesterday class, Monday class, this is was like a t value. The t value equals pi over 2. So here, the t value equals pi. This one, t equal to 3 pi over 2. The first one, I can check. Was it like a tangent line at t equals to 5 or 6? T equals to 5 or 6, we have this one, this angle. So this angle is like a 5 or 6. We have this point. You can draw tangent line. So like this. Yeah, slope is negative root 3. The negative root 3. Y-intercept is 2. So here, meet this point. This is like a 2. So we have it. So another one, horizontal tangent line. We have horizontal tangent line here. Horizontal tangent line here. Yes. 0, 1, 0 and minus 1 was a t value. Pi over 2 and 3 pi over 2 is right. Pi over 2 and 3 pi over 2. We have two horizontal lines. Was it like a vertical tangent line? This point. We have vertical tangent line. Here, vertical tangent line. Yes. 1, 0, minus 1, 0. What's the t value? 0, pi, 2 pi. Here. 0, 2 pi, and pi. It makes sense. The last one, what's concave of? Here, the t value is between pi and 2 pi. Here, t is pi and 2 pi is this graph. This one. Yeah, this is concave up. Yes, concave up. What's concave down? T is 0 and pi. Here, t is 0 and pi. Exactly, upper semicircle. Upper semicircle is concave down. So this makes sense. That makes sense. Okay, so this is like all for today's lecture. Some the tomorrow I will give some the more examples and section 10.3 the tomorrow class. Thank you for watching my video.